Hi everyone. My goal today is to talk about memory behavior on Node.js. I will presentate me. My name is Raphael Amorim. I currently work at global.com. I'm working with language like Node.js as platform, as JavaScript on server, obviously, and Elixir and Golang there. By the way, I am a member of JS Foundation and jQuery member, maintaining projects like jQuery Color, and also I am Mozillian, and no one cares. Here is if you're looking for new challenges, we have a lot of several job open in. Have several jobs open in global.com, so you can send me a mail or apply in one or more, or see the link. Okay, let's go. Try. Okay, better. I have one question to you guys. Would you board a plane programmed by JavaScript? If you so, raise your hand if you listen me. Who? Oh, okay. Have so many courageous guys here. No judgments here. Okay, I will board in too. But I asked this question recently, and for myself, the answer was scary. Detail. I asked it in 3 events of JS, focus in JS, that I have spoken, and only 11 people raised his hands. The scary part is, it's all of the sum of these events is more like 500 of attendings, or more than 500. So it instigates me to the point of researching to the community, to my company, only to know the reason for this insecurity. In the end, I realized something. Developers, not all, I not make generics abordage here, but don't consider or just doesn't know how tricky memory management can be in Node.js. Obviously, I identify other things, such as spec behavior, JS, from developers who migrated from other platforms or other languages. But today, we only focus in Node.js and memory behavior. I like to introduce other topics before we begin, just to pass concepts that all of us know. Computer memory is any physical device capable of storing information temporarily or permanently. Okay, physical devices are limited. Despite Amazon or Heroku says, on global.com we have our own infrastructure. This means there is not so simple to start 100,000 of apps with max configuration. It's like use memory like you wish, no problem with it. There's not our reality. So the cloud is a computer from other people. Cloud is a lie. Memory is limited. Okay, then we know memory is limited, so let's go back to Node.js. I'll be talking about Node.js ecosystem and its all characters in this section. But before, let's meet V8. I have sure that everyone here knows V8, but please let me talk about it fastly. V8 is a JavaScript runtime engine which compiles and executes your beautiful written JavaScript. V8 comes with generational and stop the word garbage collector, which I'm going to explain later. Initially created for Google Chrome, but it also can be used as standalone or embed into any C++ application. So I always like to say that 83 of all interpreters are written in JavaScript. This is a fake number, as you can see. But this is important to understand one thing. Data structures generated from V8 not similar than JS usual structures. So in 2009, Nodejs was born with the idea of manipulating tens of thousands of concurrent connections on a single physical machine. This was made by Ryan Dow. Dow was inspired to create Node.js after seeing a file uploaded progress bar on Flickr, and he realized that the browser didn't know how much the file was uploaded. And he had to ask the web server. I don't know why he made it, but okay, Node.js is born. So Node.js is a C++ program controlled via V8. Remember that V8 can embed on any C++ program. So it means when we talk about Node and carrying its all properties and characteristics, like dynamic memory allocation, which it means when programs allocate memory, they can do wherever and whenever they want in runtime. Weakly typed means the compiler, if applicable, doesn't enforce correct typing. Without implicit compiler interjection, the instruction will error on runtime. This means when your code goes wrong and doesn't have any method to run, that probably will break in runtime. There's another property and characters. Its name is called by V8 stop the word. This is specifically V8 characteristic, which is stop the program however long it takes to scan the entire memory heap. So scan for, say, a program a couple of milliseconds and let the program resume. Probably many of you guys hate this in Node.js because stop the entire program and okay, let's resume it. And generational. But I will talk about it later. But for now, it's nice to understand that it helps a lot to Node.js identify memory life. Okay, let's talk about garbage collection. I would describe some particulars of V8 garbage collection mechanism. So every programmer knows that every program have a mechanism for reserving and freeing space. Okay, it's no big deal, no news, but particularly in C and C++, we have methods to help us to do that job. We have malloc for allocate memory, and we have free for deallocate or release memory. So let's dive in a simple scenario that I want to show where there's no direct connect with Node.js. Here's a simple C++ code that creates a string, which is a pointer of many chars, allocated it, and the next step is the allocator or release. Okay, move forward. But what this means, what the hell are you trying to say showing this code? In this case, C++ programs, the programmer is responsible for freeing heap and memory that's no longer required. Okay, but only in C++ language. Okay, programs make mistakes, happens. We have the power to do the right and the power to do the wrong. Let me show one case where it all can be very wrong. We have a C++ operator called new, which allocates heap memory, and the delete operator frees heap memory. For every new operator, you should use delete so that you freeze the same memory you allocated. No problem here, no memory issue here. Okay, let's move forward. So now let's try to reallocate memory only if you have deleted. So in this code, this variable acquires a new address with the second allocation. The first address is lost. So these 30 bytes, if you consider like 1 byte for one char, that you have pointed, now is they impossible to free, and now you have a memory leak. So when you fail to remove data, then you cannot be referencing, or when a portion of memory allocated for certain operations not released, when it's no longer needed, okay, there's your famous memory leak. It's very common in our lives as programmers. Garbage collector is a double-edged sword. Where is really a double-edged sword? Because we have the positive side. Language that use it become more simple, because it allows a massive simplification in languages. So since memory is no longer need to be managed or explicitly by programming, you have the simple. It's more simple to create stuffs. It's reduced, but does not eliminate a large class of errors, memory leaks, which contains large long-run applications cases. For some programs, it can even be improved performance. So we have a negative side, no control of memory. In this case, it's applied for Nodejs. ECMAScript specification doesn't expose any interface to garbage collector. So there's no way to for app to measure its memory usage or even provide any hints to garbage collector. It's not possible to do it in Node.js. But performance of garbage collected languages is not strictly better or worse than language without managed memory. What are I talking about? You saying your life in the universe is a lie? No. If you consider the C, and allocating and free objects can be costly. So since heap bookkeeping tends to be more complicated, if you need to free objects later, with managed memory, allocations usually means to just incrementing a pointer. So you doesn't have to be careful what you're doing for memory, or it can be a lot of cost to program. But as we'll see, you have to pay for it eventually when you run out of memory and the garbage collectors kicks in. So performance of garbage collected language, okay, there is it. But poorly implemented garbage collection systems can lead to long, unpredictable, and embarrassing pause, which means interactive systems, especially those with animations, is frustrating to use. So V8 have a memory scam, which have a resident set. The words means resident set is a running every time a running program is running. A running program is always represented by through some space allocated in memory. This is resident set. So V8 uses a scheme similar to Java Virtual Machine and divides the memory into segments. So we have something like this in resident set of Node.js. It's like code segment, stack, heap, and used heap. This is how resident set seems like on V8. I will explain each block, but we focus on code segment for now. This means what is proposed to means is the actual code being executed, not any news any more about it. But in this case, also we have stack variables, which is faster and easy. However, is limited. What I trying to say, it's often used for smaller values like primitives. So back into C++, a simple example, creating an array of pointers in stack for, I see 500 high to 40. So if you allocated many values on stack, the program can die. All functions run on main thread use stack frame, so it's advice for possible stack overflow. So resuming, it contains all values types with pointers reference objects on the heap. So we have other type too. It's heap variable. Is this type of allocation is dynamic, so it needs to be allocated and deallocated at runtime. This case creates 500 shards in the heap and points stack shard to them. So you create a reserve to this 500 shards in the heap, and only points a pointer on the save a pointer reference address to that heap. So it's like largest data are preferred to be allocated on the heap, but primitives and smaller ones in the stacks. So resuming it again, is a memory segment dedicated to storing reference types like objects, strings, closures. Okay, moving forward. In Node.js, we have a particular method which returns a report for memory usage. Here's a sample of this method. The process memory usage returns an object. This object describes the memory usage of Node.js process measured in bytes. So this is the property RESS, which contains value referred to resident set size. We have the heap total and heap used, which refers to V8 memory usage, and external. External refers to memory usage of C++ objects bound to JavaScript objects managed by V8. So I will be rude if I say that is all about generationals. Generates is a lot about concept and a complex algorithm about it, but I will try to simple it and to help you guys understand how generates work in Node.js. But V8 splits the heap in two categories, the young space and the older space. So when you try to allocate things or ask for allocate things, V8 puts your order at first generation. What this means? Every time you try to keep or save data on Node.js, this data is attached and labeled, which like a age. Every data have an age in this concept. However, if you be allocating things continually, you got run out of memory. So V8 starts to scavenge, which means that V8, this process scavenge means that V8 will start to cleanse to clean unusable data or trash. However, memory which is not removed from this process is promoted to older space. Usually is who survive garbage sweep. So then in the next scavenge process, Node.js will ignore in most time in the older memory. So Node.js keeps saving and saving more data in creating ages for different address in memory. So if a memory can be more old than one, in many times of a scavenge process, this memory is only removed if, I don't know, 5 or 10 times after scavenge process. Something like that is after a lot of times to remove it. So how memory allocation works in Node.js? Okay, let's go to practical samples. I saying a lot of theory here, but here's our allocation for two cases. It's a number and other for a string. So worth to mention, who knows about compilers, who reads about compilers and likes compilers, yay, compilers is very cool. Nose values is separated by L values and right values. So this is like the worth to mention how each works on Node.js. So each element in a array is not named. So even if you created a function, this will be a cycled reference. So the function here, the function inside your array sets a pointer for other place, but I will try I will explain it later. So in this case, we have array and each element is not named. Okay. So we have a fact called object select tracking. What this means? You probably should ask yourself when Node splits object memory. V8 use a guy named X. It can be rude, but something like that, to determine or define a size based on stance of constructors. So the default is 32 fast properties stored in stack. So every time a number of objects created from the same constructor, V8 checks the checks maximum size of these objects and runs and try to run out the transversal tree. So then when you create new objects, they are based on this value created previously, defined as maximum. So after each V8 changes the limits of first one with a clever trick. When it saves the reference, it says to compiler that's free and okay, will be redirected with different property. In the end of process, the settled size is reduced and going back to normal with his 32. Let's go back. In this case, we have, it's worth to mention, overflow array. So when you create a function, you probably are storing, probably not, you are storing an object called callable object. And when you create functions with expressions, they do object allocation also. And so this also becomes a part of other concepts called cyclic reference. What this means in the end. This is a case of cyclic reference. Is very simple. We have two objects and we create dynamically inside two objects a pointer for the other objects. There's not part of the same, but for V8 the only job that VH have here is create is assign the same address of the later memory setted. So when we are creating a .c and pointing to B, it's like I only set the property C is referring to this address previously created. So I would like to present some garbage collector sample. I think there's the most cool sample in this presentation. The object here, I create an object named my object, which have a lot of properties, a lot like person and name and age. So it increments counts of reference because you create an object and nothing of garbage collector job. It's like, okay, I have nothing to clean here. But, okay, let's create another object, name it another object, or starts to make reference to my object, the last object trait. So it increases the counts of reference. So we have 2 references now, which means that my object starts to refer to other, here now my object starts to refer for a number, now change the value, so decrease the count of reference. Now, however, the another object still refers, however, the another object still have the reference for my object, it can be collected. So if you are creating other object, name, I don't know, name it yet another object with only refer to another object property person, it increases the counts of reference of my object. My object, again, cannot be collected by garbage collector. So we have 2 references for my object. Now I change my value of my another object to strings. I think the counter decrease because we have only 1 point for my object previously defined. It's the first object defined. So, however, yet another object can be collected again. So yet another object is change value for null. Counter decrease, no more reference to my object can be collected. Okay, remove my object from memory. So let's build a leak for ourselves. It's right. It's easy, right? And it's a very, very simple job. In JavaScript, it's very simple. You have here a function named leak class, which consider like we are using construct property of this function, which does do nothing, and we are creating a variable named leaks, which in the truth is array, or is a simple array that we can push this reference of a lot of objects to array. So every second inside this, we are creating a leak, or creating some data expired from the other data. So it's fun. Let's create another. We have other case here. We have this simple function that executes only gets the developer.name and do nothing with that. But consider that there's doing a bunch of work in this function do work. So this variable developer property name is used by the work. Okay, let's create another. I kind of liking to create memory leaks, but consider this code is more complex, but not so many complex, but we are creating a server. So in this server, we are considering that every request another 1,000 leaks listens. Okay, but how I can debug this? How I can debug a leak? It's very simple, but let's go back to leaky examples. For this case, leaky.js, the last case there you're pushing a bunch of objects. So we have node inspect flag. So what these flags do, this is a case where executing it's like node file that do the same job, just run the script, but with node inspect flag there it creates a debugger browser which can be accessed, so we can start to debug this Node.js here variables and get their memory footprint, get all the information about data. So here, this is the first screenshot. So I don't know if you guys can see, but it's like five, but after I think I run it after 10 seconds, you see like growing and adding a lot of memory. So I have two hints here. You can also send this signal for existing node process to be only to enable inspection mode. And the second hint here is very important to name your functions or constructions or closures. Otherwise, the heap snapshots will not produce useful outputs for you. But this leak is very simple to debug. Just imagining that you're using a node module, and this node module have a closure function which is not being named. So then you're using it, and it produces a memory leak. How to debug it is very complicated. This is a simple sample where you control it. I show okay, I have an image function here. Okay, let's debug. But in real life, it's not like that. So we have the second sample here is server leak. Is the leak from the server. So I would like to recommend you to use one of these libraries. The Node man watch is the main libraries, however, is no longer maintained, but is like Node man watch. Node man watch. The applause here. Try to unfocus me, sorry. This node main watches the main node module, however, is no longer maintained. So this main watch next is like community takes this node module and okay, let's maintain it. So have a lot of forks from node main watch, but it's a simple case of using it. So it's like running node server leak, okay, no big deal. And using Apache benchmark here, but you can use anything that you want to. So I trying to make a lot of requests for this explicitly route. So okay, let's complete the number of requests, okay, but the nice thing of this node module is for every event there is for memory leak or memory sweep or things like that. He can send you like a string event, so you can control it. But there's a lot of other tools to help you. Node man watch, Node heads up is like the inspect flag. So when in Node older versions doesn't have this inspect flag, is like a debug flag. So you have to use debug flag, but it's not so completed by like inspect flag. So people like 2 years ago used a lot this Node module, but still useful. Have this Node inspector is node time v8 profile who can gives you a print for profile. Main watch next, that is the one that I said before. And go back for this leak from closure. In this case, we have to maintain developer in memory, because do work doesn't know develop it. It's a global scope that you can access by this closure, but for node memory, for V8, you have to maintain this memory when still this memory is useful for this method. But it's like a trick, because most developers don't know that it can be a shoot in your foot. So it's like developer, only if you point in developer for null, okay, you doesn't have more problem, the leak is solved, you know. But what's the rub about everything that I said before? This ecosystem about Node and memory management and memory behavior and things like that, it's more complex than I said. There are a lot of concepts like marking, sweep, in-scar, range. This process and algorithms are very complex to speak about, to talk about. So I try to resume only the sweep of memory. So even valid code can cause memory leaks. Is like a truth for our guys which develop with Node.js, because we doesn't have any the ECMAScript doesn't support us with this API for custom memory management, so we doesn't have any place to run. We have to accept this fate. It's like, okay, my code will be leaked in memory, but what I can do for solving it is like you guys using Atom or other editor, like using Electron. It's like there's no not like work to do. It's like maintaining it is solving memory leaks. But the useful code that I say is like put the null at the end of things. It's like all your days be saved, and this is the reference who these brilliant guys. There's a link for V8 week there. I recommend a lot to understand these complex concepts, and there is it. Thank you guys.